there exists an alpha 0 such that 0 is in A alpha 0, B alpha 0. In a picture, this is what's happening. Here is 0, this is A alpha 0, and this is B alpha 0. Does it make sense, guys? Does the picture make sense? Yes, Merlin? Yeah? Okay, good. Now let's take a look at the sequence. That's my open set. If you are a little bit confused, think like this. You have a point and you have an open set like this, okay? So if it's hard for you to work here, work here. Alright, so the sequence starts like this. 1, 1/2, 1/3, 1/4, 1/5. And then at some point what happens, guys? At some point the sequence enters, right? Enters into in that interval, right? Boom! Crosses and boom, it's here. And then it continues its path, right? You guys agree? So how do I know, how can I assure, how can I find the moment at which the sequence enters into that interval? Yes, Adam?
I think n is greater than 1 over b alpha 0. Or even easier to take.
So see, Adam is talking to the angel right now. It's like, how do you find the mod? How do you find the n? How do you find this natural number? Well, by using the Archimedean property. So you go like this. So in case you don't know the angel, I'm going to show you how to talk to the angel. This is a personal relationship. So here's the moment when it enters. It's called 1 over n, right? So how can I force, and this is the alpha 0, how can I force that situation? So this happens when 1 over n is less than b alpha 0. So you force the situation. You force the sequence to enter, to be this guy less than this guy. So just move things around. 1, multiply both things by n. Divide both things by b alpha 0. And which is actually positive. This number is positive because 0 is in there, so 0 is less than b alpha 0. So 0, this guy is positive, so the inverse doesn't change. There, you found the moment at which this happens. This is the moment. This is exactly what Adam was saying. Take an n bigger than 1 over b alpha 0. That's how you talk to the angel, but you just write it backwards, right? So the right way of writing it is like this. That's scratch. And so you say the number 1 over b alpha 0 is a real number, and go by the Archimedean property. There exists a natural number such that n0 is greater than this guy. n0 is greater than 1 over b alpha 0. So go ahead, multiply both sides of b alpha 0, inequality doesn't change. Divide both things by n0. Alright? Then, so we were looking for a natural number, we found it. We started with an open set that contains 0. We found the natural number. Now we say take n greater than or equal that n0. And my goal is to achieve that xn is in the open set. And then, in this case, therefore, if n is greater than or equal to n0 and n0 is greater than that, then n is strictly bigger than 1 over b alpha 0. Hence, b alpha 0 is greater than 1 over n. And that I achieved it. Why? Because then, this is what happens. I achieve it. Let me show you. 1 over n is less than that, so it is 1 over n is certainly greater than or equal to 0. I beg your pardon? 1 over n is in this set, in this interval. B is above 0, which is a subset of A alpha 0, comma B alpha 0, which is a subset of which is a subset of G. Why? Because G is formed by all those little pieces. And this is only one piece. So of course it's a subset of the G1 set. So you took an n greater than or equal to n0, and you achieve that 1 over n is in that set. So put all those boxes together, say since G was arbitrary, we conclude that for every G open set that contains 0, there's a natural number after which 1 over n belongs to the set G. Hence, therefore,
In the sorting topology.
1 over n converges to 0. Yes, because we started with an open set in the sorting rate topology. Right? Yes?
What prevents the situation where you have 0 to some number union, like some smaller, like a tiny distance? I don't know what I'm trying to say. Like you can have, like, is that always true that 0 to b sub alpha is always a subset of b sub alpha?
Oh, yes, because 0 is in this interval. So that means 0 is greater than or equal to a sub alpha 0 and less than b alpha 0. Right? So that's the reason this interval is completely inside there.
Yeah.
Because this number is actually on the right of this guy. Okay, that's a good point. Alright, so that's it. So here's one more example. One more example. In the sorting frame topology, again, in the sorting frame topology, negative 1 over n, okay, 1 over n converges to 0, right guys? Do you guys agree? Okay. Negative 1 over n, negative 1 over n. Say it louder, guys. Exactly. You are so wrong. Let's not converge. Yes, Jay. Jay, go for it.
Never mind.
So this sequence does not converge. So first, I want to prove that negative 1 over n doesn't converge to 0. Why? Because it's false that for any open set containing x, blah, blah, blah. In fact, I'm going to find an open set where this thing fails. So take or consider the open set G equals 0, 1. Do you think that is an open set, yes or no?
Yes.
It's an open set, yes. It's in the sorting frame topology, it's an open set. Do you think it contains 0, yes or no?
Yeah.
Now, do you think the sequence is inside this set at some point, or is always outside? It's outside because the sequence is negative, right? It comes from the left, so it never enters. It never enters, right? Sequence. In fact, sequence never enters in the set, right? You guys agree? So it cannot converge. It's kind of weird, right? It's kind of weird, guys? Yeah? Well, there are weird things in life. If you thought you were weird, forget it. There are weirder things in life, okay? It's not even at all weird. Can I... Oh, wait. So you may say, well, Professor, it doesn't converge to 0, but what if it converges to something else? You see, that's a good question. So, but what if negative 1 over n converges to something else? Well, that's not true. That's not true. So there are two cases. So assume negative 1 over n converges to some x. Case 1. Assume that negative 1 converges to x. Case 1. Maybe this is a problem from the homework, I'm not sure. Okay, case 1. Case 1. X is greater than or equal to 0. Do you think the sequence is going to converge to a number x that is greater than or equal to 0? No way. Because this is 0, this is x. The sequence is right here. You see what I mean, guys? So it doesn't converge to x because if you take this open set, actually this open set, that open set contains, it's part of the, it's open, that set is open. It contains x, but the sequence never enters there because the sequence is negative. You see what I mean, guys? So this is, considering g equals 0, x plus 1, which is open, and x is in g, we conclude, considering this gives a contradiction. Why? Because on one hand, I'm assuming that the sequence converges, so therefore the elements of the sequence must be in that open set after some point. But it's a contradiction because the sequence never enters into G. How do you say enters G or into G, guys? Into G. Okay, I'm trusting Adam because he just took an English class, right, Adam?
Yeah. All right.
Case 2. X is less than 0. Oh, that's a tricky situation. This is the situation. Here is 0. Here is x. And let's take a look of this number. Let's take a look of x, comma, x halves.
Negative?
No, x halves. Because x halves is on the left, for sure. It's on the right of x, right? But it's negative. And it's bigger, right? X halves is bigger than x. So, here, g, consider g equals x comma x over 2, which is open, and x is inside. Yes, the sequence may enter into G like this. Check the behavior, okay, because this is more intuitive. It enters into G, but guess what happens after that, guys? It leaves because it's getting closer and closer to 0, right? You see what I mean, guys? It enters into this, but it leaves at some point. How do you find the point at which it leaves? Well, in fact, you can say in fact, comma, in fact, it leaves for n greater than or equal to 2 over x. That's the moment after which it leaves. Because for sure, 1 over n is going to be it's not going to be 1 over n is not going to be in this interval, because if you take a look of this, n greater than 2 over x, what can we do on both sides, guys? I'm going to show you the algebra. This is algebra. If you multiply both sides by x, what do you get? nx is no, it's less than or equal to 2. Why less than or equal? Because x is negative, and it flips the inequality, right? So divide both sides by n. X is less than or equal than 2 over n. Hence, No, divide by 2 both sides. Also divide by 2. Hence, 1 over n is not in the interval x halves. Because if it were, 1 over n should be less than x over 2, but it's greater than or equal than x over 2, right? So it definitely is outside, yes.
So we chose 2 over x as our answer, 0.
Yes, yes.
How is that possible if that's negative?
Oh, no, because this is a natural number. I'm sorry, this is a real number, right?
Yeah.
This is a real number. Oh, wait, hold on. You're right. Hold on. Yeah, you're right. Hold on. Hold on. Hold on. Hold on. Yeah, you're right. So I want, you're right. I want negative 1 over n to be
Greater than
oh. Hold on. I want negative 1 over n to be greater than x over 2. Let's see if I can achieve it. Yes, yes, you're right, you're right. This doesn't guarantee anything. So I'm going to put negative. I'm going to put a negative. Yes, you're right, negative. Put a negative, put a negative, put a negative, and put a negative right there, and then put a negative right there. Yes. Now that makes sense. Yeah, because I thought I was working with 1 over n, but I'm working with negative 1 over n, right guys? I'm working with negative 1 over n in this case. And so that's it. Alright. Good observation. I'm sorry for making that mistake. Yeah, we're talking about negative 1 over n, not 1 over n. Alright, so here is one example. So consider let x be the real numbers, and let's take a look of tau equals just a slightly different topology about the empty sets and the real numbers. Which is that, what's the name of that topology? Is that the discrete or the indiscrete? I forgot. Indiscrete, right? Why indiscrete? Indiscrete. There are 2 topologies: the indiscrete topology and the discrete topology. What's the only difference between both of them? The indiscrete has only 2 elements. You guys agree? So that's how I remember that, right? When I said, oh, I don't remember, I was just kidding, but I want to make sure that you guys remember, all right? Many times I lie to you guys. I said, oh, I don't know. Okay, here we go. Consider 1, 4, 9, 16. Do you recognize that sequence?
Yes.
What is it? What's the next one?
45.
5, 36. So what's that sequence is n, come on, n square, right? N square. Jory, how many, can I ask you a question? You can fake it up if you wish. How many girlfriends have you had overall on your life?
10,000.
How much?
4.
4. Okay. Wait, minus? Let me ask, how about that? Someone else. Merlin, how much money you have in your pocket right now, or in your bag or in your purse? And how about more cents? $4 and $4.25. Does that sound stupid? That sequence converges to 4.25. Is that stupid? Yeah? It is stupid, right? It is stupid.
I don't know, you're a trickster.
Well, I'm asking you, do you think that's true or false?
True.
Yes.
I
Joseph.
thought n squared
by itself diverges.
Good. That's the reason I'm asking you. Is this true or false? Joseph, what does your heart tell you? This time, don't go with your logic. Don't put your mind away. Go with your heart.
I think it's a trick question.
Is that true or false?
I don't know.
Go with your heart.
It's a trick question. It has to be.
Just
No, I'm asking you to make a decision. In your life, there are going to be situations where you don't have time to.
It's true. I believe it. It has to be right. Next person. True or false?
Ross.
He's only going to do that.
That's true or false? Like n squared converges to 4.25. It's true? What if Marlene said, actually I don't have $4.25. I owe $4.25. I owe some money because or something. Do you think that's true or false? No, that's not the reason.
Are we taking a side?
No, we're not taking songs.
I'll say it's
Taking
false. Just
sequence.
pick on the I think it's false.
Okay. All right. So let G be an open set such that negative 4.25 is in that open set. Just Eric, can you give me an open set that contains negative 4.25? Give me an open set that contains negative 4.25. Only Eric can answer this question. Eric.
Negative 1 minus 5.
G equals, say it again.
Negative 1, negative 5.
That's not open, Eric. That's not an open set. Sarah, can you give me another open set? Well, actually, an open set that contains negative 4.5. Sarah, I'm sorry, did I hear another Sarah somewhere?
No, me.
Okay.
Okay, so, the bracket, and then negative 5 to what? And then,
Including or excluding?
or x,
Excluding or including? I want to go with you, not with someone else.
okay, excluding.
Excluding.
No,
Are you sure?
no, including.
Including. Are you sure?
Yes.
Okay. That's not open.
Oh, okay. Then
Oh gosh, all right. All right, Marlene, give me an open set that contains negative 4.5. Marlene, okay, only Marlene. Whatever you want, just tell me an open set that contains negative 4.5. Zero to negative, like negative 5.0? Including or excluding? Including like this? Including or excluding? Including. That's not open. All right. Okay, how about I'm going to ask Haley. Are you Haley?
No, I'm not.
Okay, Haley. Yeah, that's open. Yeah. Yeah, that's open. Is there another open set that contains negative 4.5? 4.25? No, because the only open sets are the empty and the real numbers. There are only two open sets. This doesn't contain negative 4.25. The only open set that contains negative 4 is this number. You get it, guys? All right. I'm going to draw the situation right here. This is negative infinity to infinity, and this is G, and this is negative 4.25. Now, do you think from your heart that the sequence enters into this set? Into this set at some point? In fact, it's born there. It never leaves. Right? Which one were you born at? Which country? America. So it's like saying, do you think Adam enters into America? Yes, he was even born here and he never... Have you left America? Okay, I'm sorry. How about the world? The world. Have you been in another world? Yeah. The sequence stays here all the life, right? It's like here, the sequence goes like this back. It's like 1, 4, 9, 16, 25, 36, 49. What was that? 64, 81, 100. The sequence stays there forever. It never leaves, right? So the sequence ends. So in fact, there is a natural number. And how many references do you say you have had? 4. Namely, n equals 4. Namely, n equals 4, such that for any n greater than or equal to 4, the corresponding term of the sequence, which is n squared, is indeed in this set G, which is the real numbers. So do you think n squared is a real number? Of course it is, right? So that's it. For any open set that contains G, there is indeed a natural number. After that natural number, n squared is in G. You put all those boxes together, you say hence n squared converges to negative 4.25. Right, guys? Yeah? It's kind of weird, right? Okay. Let x be equal to the real number and tau equals the all subsets of R. Give me your favorite sequence. Your favorite sequence. Think of your favorite sequence. Think of any sequence that you think of any sequence. Don't say it. Just write down an example of a sequence. You have to write it right now, okay? 1, 2, 3, start writing your sequence. No, you cannot write something else. Your sequence, fast. Your sequence. Your favorite sequence can be 1 over n, e to the n, log n, whatever. N squared, sine of n, whatever. Ready? Did you write your favorite sequence? Andrew, did you write your favorite sequence? You have it.
Right here.
Okay. I bet, and I'm only going to make probably one mistake with one of you, that your sequence, whichever your sequence you took, it doesn't converge. Your sequence that you're thinking, it doesn't converge. Except, you thought of a specific sequence. Which one did you think of, Jay?
I just said one.
Which one?
I just said one.
Yeah, it doesn't converge. Which one?
I don't know, it doesn't work, but 1, 1, 2, 1.
Yeah, that doesn't converge.
0 to the n?
That converges actually, because that's a constant sequence. Any constant sequence converges regardless of the topology that you have. So any constant sequence, in fact here, the only sequences that converge are those that are eventually constant. So you may have like 1, 2, 3, negative 4, 0, 7, and then 5, 5, 5, 5, 5, 5, 5, forever. That's a sequence that is eventually constant, right? That sequence converges, but any other sequence doesn't. Yes?
Can you define sequences in this context as like recursive, like a Fibonacci sequence, or do they have to have correspondence?
Yeah, I think you have sequences that are defined in terms of previous terms. Yeah, you have usually some term that depends on the previous terms. And typically this is a polynomial. Yeah, those are recursive sequences. These are recursive sequences. In fact, there is a student whose name is Matthew Costa. Who knows Matthew Costa? He's working on Fibonacci sequences. And we were working on some problem during the summer. It was a research problem, and then it was called Markov chains, and we were counting how many paths go from one point to another point. And none of us look at it, and suddenly Matthew said, oh my goodness, that's a Fibonacci sequence. It was so awesome. So he's working with that, he's trying to generalize those things, and it's super cool. So here's just one theorem that I'm going to give today, and that's it. And happy Thanksgiving, guys. Is it time to go?
No, but you give us that one.
What time is it? Let me see.
105.
106.
What's that?
You have a watch?
Yeah, you're right. You're
It
right.
takes longer to read the watch.
You're right, Sarah. I'll give you extra points for that. The theorem is if xn converges to x and xnk is a subsequence of xn, then xnk converges to the same guy. Converges to the same point, to the same point. Now, you can write it like this, or you can write it like this. Or you can write it like this. Whichever you prefer. So which one is your favorite? I know students already. I know that 75% of you are going to say the first one. It's kind of shorter, and you students love arrows a lot. But sometimes you use arrows in your homework, and I don't know what those arrows mean. They mean convergence. That's mean therefore. That's mean equal sign. It's kind of weird. So try to drop it from the homeworks unless you're using convergence. Okay. So we'll improve it like in 1 minute. So let G an open set that contains X. Since Xn converges to X by definition, there is a moment after which Xn is in the set, in the open set. In the sequence, xn1, xn2, the smaller that this number can be is 1, and 1 is greater than or equal to 1. The smaller that this number can be is not 1. What is the smaller that this number can be? 2. So n2 is greater than or equal to 2 for sure. What is the smaller that the next one can be? N3 is greater than or equal to